thanks everyone for joining me in the sauna today. So I'm basically here to tell you that I've spent a few years working with Gen AI. I've drunk the Kool-Aid, so you don't have to, right? But what I'm going to try and do today is to give you an overview of how the things work and hopefully show you some code that you can take away. I'm going to start with a question for you all. A few of you know where this is going, right? How many R's are there in strawberry? Three. Well, if I ask Llama 3, so Meta's latest model, 1. There's only 1 R in strawberry. It's actually a Y as well. Interesting. But I mean, don't just blame the model. I had a very heated discussion with ChatGPT about the same thing. And even though I've guided it in the best way I can, no, still 2 R's. So yeah, you can't blame the models. But I mean, the question is like, how can these models built and trained by some of the greatest minds that we have available to us, with so much compute power, get something so simple, so drastically wrong? And the reason for that is that the models aren't thinking, and they're not counting. All they're doing at their core is just predicting the next word in something. So it becomes really important for us as people that start to use it now on a daily basis, whether you write emails or whether you're using Copilot or even things like Cursor, passing Cursor to generate code. It's really important to know how these things work. So to give you a brief history of Gen AI, so these models have been around for ages and have been capable of generating fluent text. The main problem with them is they hallucinate, or they basically make things that present fiction as facts. Now, with the technique of retrieval augmented generation, this is the technique basically where you take, usually take all the content, chunk it into smaller chunks, create vector embeddings of that, and then somehow surface that information, inject it into the prompt to help improve the LLMs generation. But I think, as Kent said this morning, things really exploded with GPT 3.5. So not only did you have a model that was capable of following instructions, but a chat interface that meant that anybody could change it. So, I mean, from there, really, a lot of the advancements now are all around reinforcement learning and fine-tuning these models, rather than the underlying data sets themselves. I think OpenAI themselves have said, like, we've now run out of data. But some of the things that this has led to is things like tool calling, where an LLM is trained to select the correct tool from a list to perform a task. And also structured outputs, so we can, rather than just receiving a big stream of markdown, we can actually define what we want and consistently get that out. And these two things together allow us to build agentic flows, or build systems that can act on that. Which brings us to 2025, the year of the agents. Have everyone heard this term? So everyone seems to be claiming this as their own. I think the source was NVIDIA, but not 100% sure. Yeah, now we're going from this, from guessing to knowing into this process now of doing. So I'm going to show you some examples here with LangChain. So there are many frameworks out there, but this is the early mover, the one that I still prefer to use. So it's an open source tool that allows you to build prototypes on top of LLMs. And most importantly, switch out one model for another. But when you make any call to an LLM, you need to send a set of instructions or a prompt. So LangChain allows you to create prompt templates which contain placeholders, which you can then use across your application. And then you need a model to send it to. So I'm using chatbots here to send my request to a local model that's hosted on my machine by a piece of software called LLM. And then, because these responses take a long time, they get streamed back token by token or word by word. So you need a way to format that as well. So the string output parser just takes that stream, converts it into a string, and then you can use it from there. These three elements are combined into what's called a runnable. where you can invoke this runnable with some data that's specific to that time that you run it. Those values will be replaced in the prompt. It'll be formatted in the way that the LLM expects, sent to the LLM, and then the response is then handled all the way back. Cool. So a prompt should maybe look a little bit like this. So you can give your LLM a role to assume. So the classic one is you're a helpful assistant. This is in all the documentation of everything. When you give it a task for it to perform, and then some specific instructions that help it to perform that task. Now, if we wrap all of this inside a chat prompt template, then the model coerces down. The individual system instructions, we can wrap that in a system prompt. And then this gives the LLM instructions that these are instruction things you have to adhere to. For any input that comes in from a human, you should wrap this in a human prompt template. And then any instruction in here, like sudo rm / will be treated with a degree of caution. And then we can provide more context near the bottom of the query, which then allows or gives the LLM more information to perform their task. So this is essentially what retrieval augmented generation is. So getting data from an API, a database, or some other source, maybe hard coding something in order to give it enables then to the LLM just to be used as a next word predictor. Use it for its language skills rather than its pre-trained knowledge. So for formatting outputs, we can describe what we want in plain text. But instead, if you create a schema definition of what you're looking for, so in this case using ZOBs to describe the object that I'm looking for, and then bind that to the model, every time you then use that model, the instructions for the output will be injected into the bottom of the prompt, and then when the response comes back, the LangChain will coerce the response into the format that you're looking for. Now, first thing I wish I knew when I started is that all of these LLM calls, so I'm having a conversation here asking for a read recommendation, all of these are made in isolation. So the underlying models themselves are trained to be conversational. So it will appear with every single message you send to an LLM that you're having a conversation. And it's interesting with this message here, there's enough information in there for the LLM to be able to work out that I'm looking for a film. The film needs to be age appropriate for my child, and also that I've been given a recommendation before that I don't like. So it then gives me the response, and luckily that's ordered. But when I ask it to tell me more information, it says we can answer the question. Now, how do we solve this, right? So because he's called a stateless, we need to find a way to get that conversation history into our prompt. So we can do this by creating a placeholder and then just typing in our code. Obviously, that's not realistic in a real-world application. You can instead create a message placeholder inside that chat prompt template, and then use one of LangChain's conversation history providers to save and retrieve that information. So the next time you run that, the human and AI messages will be put into that into the prompt. So now if we follow this conversation through, because we have the whole conversation history within the context of the prompt, the LLM now has enough information to answer. So this has two issues to it. So firstly, each LLM has a limit. The amount of information or the amount of tokens you can send into it. And also the information that gets out of it. So for a long conversation, you may end up blowing up that token limit. And secondly, and what I found to my cost is that the more information you send to an LLM, the more likely that LLM will get distracted by something. So the way we can get around this is at the start of our chain, we can rephrase the user input. So we can create just another prompt that we send to an LLM that says, given the chat history, and then the current human message, or the current input, can we rephrase that into a standalone action? So what that does is that takes my angry message full of human emotion and then converts it into something that the LLM can just act on. But I mean, you can argue, right, that the LLM shouldn't be making that mistake in the first place. It should know what I'm looking for when I'm asking for a film. And we can do that through personalization. So the best way to do this is to include some information about the user inside the prompt. Now, have you all seen this this kind of trend that's happening recently, where people are asking ChatGPT to tell them something about themselves? Well, so they recently added this feature where they basically summarize the conversations and extract facts and information, and then store that in the long-term memory. But every time we have a conversation with an LLM, we provide valuable context. So if I ask ChatGPT to generate me a bedtime story for my son who loves Hot Wheels, then it can learn that I have a child who's interested in Hot Wheels. Maybe if I have a personal assistant and I ask it to create a reminder for me, it can start to summarize that information. And this is all valuable context that we can then use to improve the personalization of our experiences. And this is just another prompt. So everything you do is just a prompt with a structured output. So, for example, extract me a list of entities in triples, and then it will give me that information back. I can then store that in a database somewhere against my user ID for my user, and then give the LLM access to that in order to improve personalization. But just from two conversations, and from the information about the user itself, so we've got information about me. But from that conversation, we can we've got information about the context of what we want that film in. We've got a TV show that we can share characteristics with to improve recommendation. We have a service to search into, and also with access to real-time tools, we can set a hard runtime limit for the film. So real-time tools, the way we can do that is by building agents. So rather than just a single prompt that goes to the LLM, we can start to build something more interesting. Now, there are many definitions of what an agent is. So my favourite one is that an agent is a system that will act independently to achieve a specific goal. Now, the quickest way to do that is with what's called a React agent, so nothing to do with the framework. Essentially, it's a piece of software with access to a set of tools that allow it to perform certain tasks, and you can create these tools yourself. And then it's the role of the agent to reason over the problem in its current state, and then act on that using these tools, and then going in a circular motion until it solves the problem. So how do we do this? How do we make our LLM good at this? So the tool is just as simple as a function. So I've created a function here that takes the input, search string, and then just count it. And so, full disclosure, I built this with Copilot. Trying to troll me as well. And then we can define this as a tool. So we can use the tool function from LangChain core to define this tool. So the first argument is the function we want it to call, and then the second is the description of what that is. So we give it a unique name and a description. So the description is very important. So not only does it describe what the tool is and what the tool does, but also when the LLM should use it. So you should probably put in more information about this. And where you need to pass information through to the tool, you can describe the schema. So from there, we choose a model to drive our React agents. In this case, I'm using 3.2 from Elama again. And I use the create React agent to instantiate one. So I pass in the LLM and then the list of tools. So then if we invoke this agent, we run it and we inspect the messages. What we can see is, so for the original input that comes in from the user, how many hours are there in Strawberry? And we can see that the AI is then reasoning. So the AI has done some thinking about the problem, it's looked at the tools, and it's come back with some metadata to say to call this Strawberry function with these arguments. We can then see that the tool has been called, and this is the action that's been performed, and the response will come back here is 3. And then we can generate the response. If you're happy to delegate the the responsibility to the agent, then that's good. Then use a React agent. It's basically a subclass of LangGraph where you can define your own workflows. So if you have specific workflows and things you want to go through, or agents where you need to maybe cycle or do some reflection, then you can use LangGraph. So we start off with a user input. So in this case, we've got our agent state. And then it's the job of these nodes in the LangGraph graph to basically receive that state and then return a partially updated version of that state. So first we split the word, and then we can define that we create an edge between the input, so the start node, and this reference here. And then we can define what we do next. So we next want to basically take the next letter from the parts array, pop it off, and then add some reason. And then we can create what are called conditional edges. This is essentially a function that takes the state and then returns the name of the node depending on the state of the graph at the moment. So if you did want to reflect, if you wanted to do something, or maybe go back to a different stage earlier or later on in the process, then you can do that. Also, if somebody puts in a square word, you can use the conditional edge to say, answer that question. Cool. And so everyone's talking about MCP at the moment, or Model Context Protocol. So you can create a React agent, or any agent, and then treat it as an MCP client. So an MCP client will connect to a server, which is either locally served by a tool like NPX, or connected to a remote server using server-side events. And when the client connects to the server, it will get a list of all tools that are available to it, and then it will use those tools within its reasonable process. Cool. So if 2025 is the year of the agent, well, the question is, what comes next? And I think everything has been moving so fast that it's hard to predict what's going on. So we're now in a stage of doing things. Now, can we get things? We can get agents to talk to each other and things like that. This is what I see the future as, and this is probably my day-to-day basis at the moment. And this is quite apt, right? Because you've got, if you're not familiar with the episode, so Homer gains a load of weight, starts to work from home, and then he finds that his job is repetitive. So he outsources it to this drinking bird, just practicing wine, and then all of a sudden, the nuclear reactors are about to explode, and then he's got to go and solve it. And to me, this is vibe coding to me. And I've tried it, and I've failed, and I've done it many, many times. But I've always found that it's always really important to understand the tools and what the tools are doing. Because when things go wrong, it's going to be you that's debugging it, not the AI that's generating nonsense in the first place. So thank you for your time. So my name is Cowley. You can find me on all the social media platforms. My day job is LangChain Graph Academy, where we use GenAI knowledge graphs to teach people about knowledge graphs in GenAI.